starting the turn. What do you notice about the two lines that are parallel? Henry.
Yeah.
Okay, let's count. Here's a coordinate, here's a coordinate. So up 2 over 3. Here we're up 2 over 3. So each of these have a slope of 2/3. Okay, so Henry is saying that parallel lines have the same slope. Does that sound reasonable?
Yeah.
Okay, yep. They're never gonna meet, and so they're always gonna be the same distance away from each other. Okay, good. Does it matter if their slopes are positive or negative or 0 or undefined? Nope, as long as their slopes are the same, they're gonna be parallel. Okay, what about our perpendicular lines here, Kari?
And then they don't touch it.
Okay, they intersect one time.
They have the same y-intercept.
Okay, that might be like a special case. They're not always going to have the same y-intercept, but that is something that is true about this particular picture. Cassie? Oh, one's positive and one's negative.
Ah, good observation, Cassie.
Let's go with that a little bit further. Izzy. Let's go with that a little bit further. Did anybody count the slope?
For which one?
So this one has a slope of 2 over 3, and this one has a slope of negative 3 over 2. So one's positive and one's negative. What else? Okay. So let's put it together. They are opposite reciprocals. Flips upside down. Okay. So how about you turn to page 108 so that you can write down that parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. So parallel lines are never going to intersect and they're always going to have the same slopes. Perpendicular lines are always going to intersect. And specifically, their slopes are opposite reciprocals. So you can see that this slope is a -2 and this slope is a +1/2. Are those opposite? Yes. One's positive, one's negative. Are they reciprocal? 1/2, and this is like 2 over 1. Those are flips. Those are upside down. They're reciprocals of each other. Okay. So what I'm going to have you do, I'm going to have you slide over to that page 109, and I want you to look at problem number 1, and I want you to find me the slopes of lines A, B, and C. Find the slopes of the 3 lines in number 1.
Just number one.
Just number 1. Hmm? Aaron, what's the slope of line A?
3/1.
Okay, do you agree with Kyron, 3/1? Okay. Reese, what about the orange line, line B? 4. Okay. And then what about our green line? Drew, what's our slope? Okay. So do we have any slopes that are the same? Yeah. Okay. Since line B and line C have the same slope, we can say that line B is parallel to line C because they have the same slopes. Okay. All right, we are going to work together on number 3. Okay, this is what we're gonna do. If you are in the red or purple table, I would like you to find me the slope of line A. So red or purple table, okay? My blue and teal table, you are gonna find me the slope of line B, and then my yellow and my green table, you're gonna find me the slope of line C. Ready, set, go. All right, line A. What is our slope? 1/2. Purple table, do you agree? 1/2? Okay. Make sure everybody writes down that line A has slope of 1/2. Okay. Teal and blue table, what about line B? Do you agree with that? Blue table? 2/5? Okay. Yellow and green, what about line C? 1/2. Okay, I have a question. Are any of these opposite reciprocals? No. So we do not have any perpendicular lines. Okay. Are any of them the same slopes?
Yeah.
Which ones? A and C. So we know that line A is parallel to line C because they have the same slope. Now, we're gonna head over to number 6. If I'm going to determine if we have any lines that are parallel or perpendicular, what are we gonna need to do with these equations?
Balance. Like, make sure everything's on the right side.
What do you mean by everything?
Like the x's are on the right side and the y-intercept is on the right side.
Oh, okay. So I think what you're trying to say is if we solve for y, I think that's what you mean by balance. We solve for y, and we can write an equation that looks like y equals mx plus b, we'll be able to pick out the slope and the y-intercept, but we don't really care about it. Okay? Are any of these solved for y equals?
On B. Yeah, like sort of.
I would not say any of them are. But line B is going to be the least amount of work, right? So let's go over here. Line B. Okay. We know line B is 5y equals x plus 7. If we want to get y by itself, what are we going to have to do? We're going to have to divide by 5. Okay. So when we do that, we get y equals. Now, technically, we could write x plus 7 over 5, but is that how we are used to seeing lines being written with slope-intercept form? No. So let's break it up. We have x divided by 5. Well, I'm going to write that as 1/5 x plus 7 divided by 5. Guys, we're just going to write that as 7 over 5. Don't write that as a decimal. Don't write it as a mixed number. Just write it as 7 over 5. Okay. Do you understand why I wrote 1/5 x instead of x over 5?
Because the x value has a 1.
Yeah.
That's not how slopes work.
Okay. We want to see the rise over run. We want to see that coefficient.
Multiplying by a fraction
Good. Good. So we can tell from this that our slope is what? 1/5. Okay, great. Now let's go back and let's talk about line A. Line A is 5y minus x equals 4. If we want to solve for y, what do we need to do first? What do you say? We need to add x to both sides. Okay, so now I have 5y equals, I'm going to write x plus 4 as opposed to 4 plus x because I know I want to get it in slope intercept form. That sound like a good idea? Okay. Now what are we going to do? Okay. Let's divide each side by 5. Okay, so same kind of thing. We have y. I'm going to take x over 5 and write it as 1/5 x. And I'm going to take plus 4 over 5. I'm just going to leave as 4 over 5. What's our slope? Ooh, our slope here is 1 over 5. Awesome. Okay, let's do the same thing for line C. I'm going to give you 60 seconds for you to do that same thing with line C. Anyone want to share with me what they got? Okay, what'd you get?
Slope of 2/5.
So 2/5 x plus what?
1.
Plus 1. Okay, so if we have 5y minus 2x equals 5, we can add 2x to both sides. So now we have 5y equals 2x plus 5. And when we divide both sides by 5, yep, we get y equals 2/5 plus x plus 1, which means we have a slope of 2/5. Okay, so who's parallel? Okay. Line A is parallel to line B because they have the same slopes. Okay. Now, in my opinion, having to do that, we really haven't talked much about something we haven't done other than, oh, these two slopes are the same, so they're parallel. Everything we've done so far and everything we'll continue to do is something that we've done, finding slope, solving for y. We're just applying it in a different way, okay? And same thing down here, we're gonna look at number 7. Number 7 is asking us to write the equation of a line that passes through the point and is parallel to the given line. So we're gonna look specifically at number 7, okay? What we know is that our point 3, -1 is on our line. We also know that it's parallel to y equals 1/3 x minus 3. What is that telling us? What's 1/3? Yeah, if we're parallel to this guy, our parallel slope is the same. Right, now we have a point. Now we have slope. Can we write the equation of our line? Yeah, we have something called point slope form. That's what you just took a quiz over. Y minus y equals slope times x minus x. Right? Isn't that what we just did? Yeah. So we have y plus 1 equals 1/3 x minus 1. Which means y equals 1/3 x minus 2. Now, something that I like about teaching math is that sometimes we can have different strategies for the same thing. And I would like to equip you with another tool in your toolbox. Okay, so here we used point slope form. That's what this is. And then we did some algebra to rearrange it into y equals mx plus b. Okay, what I'm going to show you, okay, is another way to do the same thing. Okay, but without using point slope form. Okay, if we know that our answer needs to be in y equals mx plus b slope intercept form, we can start with that. Okay, what is the slope that we want? 1/3. Do we know the y-intercept? No. But we do know that we have this point 3, -1. So what I'm going to do is I wrote y equals mx plus b. I plugged in my slope. I plugged in my point x comma y. And now watch what I can do. What's 1/3 times 3?
1.
So what does b equal? If -1 equals 1 plus b, what does b equal? -2. So here's my slope. here's my b, y equals mx plus b. Two different ways to accomplish the same thing. I'll let you decide which way works better for you. We focused a lot on point slope form for the past couple days, but if you'd like to use this second way, maybe that makes more sense in your brain. I don't know. Okay. All right, go ahead and turn the page. All right. Calculate the slope for lines A, B, and C. And number 9, please. All right, Karen, what's the slope for line A?
-4, which is
Please write it as -2. Thank you. Ellery, our slope for line B. 3/1. For line B? So here's this point right here and this point right here, right?
No, it's
It's 1?
no.
What? It's 1?
Yes.
This is a dumb example. Okay, line C. Noah, what's our slope? Okay, so our, what do we know? Are they perpendicular to line B? Okay, so if these have a slope of -2, our perpendicular slope would have to be +1/2. Opposite, one's negative, one's positive, reciprocal. They're flips from each other. That's not happening, so we only have parallel lines happening here. There's nothing perpendicular. Hmm? Yeah, so I think I meant to do number 10. So like, let's look at number 10 real quick. If we look at the slope of line B, if we count rise over run, what's our slope?
-3.
I'm gonna have you try that again.
-1.
Do you agree with Henry on his third try?
Great transition.
Down to over 6. Is it -1/3? Okay. Isn't that what I wrote? I see M. All right, let's look at line A. What's our slope? DJ, what's happening? So if we have a slope of -1/3 and a slope of 3, yes, these are perpendicular because we have opposite reciprocals. This is technically 3/1. So they're flips of each other, they're reciprocals, and they're opposite. Okay. All right. Let's talk about 14. What do we need to do? Solve for what? Solve for y. Okay. So in order to solve for y for line A, we need to add 2x to both sides, right? So now I have 5y equals 2x plus 1. And then what? Divide both sides by 5. So y equals 2/5 x plus 1/5. Line B is already in slope intercept form, and so is line C. Oh, I see I have a 5/2 and a 2/5. That's cool, right?
Yeah, but they don't have opposites. They're not negative.
But they're not opposites. 5/2 and 2/5, they're reciprocals, but one of them would need to be positive and one of them would need to be negative in order for this to be a perpendicular thing. So all we know is that line A is parallel to line C because they both have slopes of 2/5. All right, we're gonna say a code word. And if Brooks actually watches the video, we'll know.
Pineapple.
Code word pineapple. He would be watching this to get the notes.
Oh, for our conversation.
So, yeah. Nope. Nope. Don't even say anything. All right, so last thing we're gonna do, we're gonna talk about number 15. And we want to write a line perpendicular to this one going through this point. All right, so here's our point. What's our slope?
-3/2.
-3/2. Oh. You agree with Henry? -3/2. Okay, so you could do one of two things. You could use point slope form, or you could use slope intercept form to solve for B. You decide which one works for you, and I want you to go ahead and continue with the algebra. Oh, Miss Holman. Either way you go about it, you should be getting y equals -3/2 x minus 1. Does it say that again?
Whenever, whenever you cut the line, it just give you the X, you're not putting the X.
So like this is the XY that we need to plug in. This is a totally different line. All we're doing is looking at the slope to identify what our slope should be in our line. Does that make sense? So we're using, okay, this slope, I want it perpendicular. So here's my slope, here's my point. I'm gonna write the line. Okay. Okay. Cool.